Let's dive right in. This is a walkthrough of the procedural wavelength asset. In a follow-up video, I will work through how the asset was made, since it's an interesting look at working with curves in Blender. As usual, there are timestamps below, the link to the asset is in the description, and it is available for free. Before we do anything, I'm going to go ahead, delete the default cube, come to the render settings in Eevee, and enable bloom. I'm also going to go to the world settings and change the background color to be fully black. You can see if I hit Z and come to the rendered view, this just makes everything darker. It usually is a little bit easier for visualizing the wavelengths, especially if they're in the visible region. Back in solid view, we're going to import the basic single wavelength asset. I designed this to be compatible with Blender's asset browser, so you can simply open this up, navigate to where you have the asset in question, and drag it into your scene. You can also use File, Append, and then grab it from the object, or you can just open the asset blend file and work with the single wavelength object directly. I like to select the end and start points, as well as the single wavelength, and use M to move them into a new collection right away, just to keep everything a little bit better organized. We'll hit Z, come into the rendered view, and you can see right away we have a simple wavelength. And it is controlled, or rather it starts and stops based on the start and end position. You can move these freely in space, wherever you like, and the resolution of the curve is fixed, so I can drag this out to pretty long lengths. Eventually, it will start to slow Blender down if you create too many points, but for most cases, it's pretty convenient. And you can do this in pretty much any axes you want. For convenience, I'm going to start by moving these both back to the origin with Alt-G rather. Then I'm going to hit G and X and just move them out so that we have a very clear, easy line to work with. With 1 on the number pad, or just the orthographic view over here, you can see essentially we have a propagating wavelength. And all of the controls for this can be found very conveniently in geometry nodes. So I'm going to go ahead, select the single wavelength object, come to the Modifier tab, and you can see a number of controls are exposed here. We'll deselect the object in the viewport just so we can see the effect of these, and the very first one is actually the wavelength setting. So if you go ahead and change this to something else in the visible region, let's say anything roughly between 400 nanometers and about 650, we start by going down to 400, you can see that this has grown purple. And it's actually a little bit darker because the intensity of purple is not as obvious to the human eye. So we're going to bring that up to about 450, now it's a little bit brighter. And again, we can see 532, common laser wavelength, there's one. If we want to go up to, say, 580, we could get something a little bit more orange-yellow, and all the way up to about 650, where we see a very clear red. We also have a number of basic controls underneath this, including the amplitude of the waveform. There's an option for angling, and this is actually to tilt this in the direction of the camera. So if I did have the start and end points kind of at unusual places in space, and I wanted this to align to my camera, that was, say, facing this way, then I would simply select the wavelength and I would adjust the angle accordingly so that it looked flat, or kind of however I wanted it to look. So you can see there, we'll grab this object, we'll reset that angle. We also have a phase offset, and this can be very useful if you have multiple wavelengths that are either the same wavelength or different, multiple objects that have the same wavelength. So if we go ahead, hit Shift-D and duplicate this, we'll drop that in place, and then we'll actually use the translation settings, which are further down, to offset this. You can see now we have a control for the phase offset, so we can actually shift the phase of this wavelength. Again, we'll come to an orthographic view to see that a little bit better, so we can shift the phase. All of these have a built-in animation, so if I simply hit spacebar or play on the animation timeline, you can see that these are moving. They actually stay fixed in space between the start and end points, but the waves sort of propagate along the path that they're intended to follow. There's a speed setting right here, and so I can change the speed of one wavelength or the other. For instance, we can make this go 2 times as fast, or if I wanted this to move in the opposite direction, I can make the speed a negative value. Underneath the phase offset, there are also controls for start and end. These are essentially curves that are being created and mapped between the start and the end point. And so you can adjust how much of the curve is visible at any given point in time with the endpoint controls. Below that, we have simple cosmetic things, such as the radius. You can see that I was making this a lot brighter. And there's also a toggle for the resolution. Now, generally speaking, it's not a great idea to change the resolution because it will also impact things like the speed. So if I were to change the resolution of one wave relative to another, it would have an impact on how fast it appeared to be moving. The translation controls we've already seen, and those are just convenient for if you want to compare multiple wavelengths in space. You can also do this by creating a separate set of empty controls and then mapping to those as start and end points, so you can move these wherever you want in space. But this is just a convenient way to use the same set of empties and to offset this, because that's a somewhat common diagram that I've encountered. Now, where this asset gets particularly interesting is underneath the offsets for translation. You can see there are a number of options for polarized circular light, polarized Y, there's an EM shift offset, and right now we're simply going to hide the 532 nanometers that I have right here. I'll take a look at our good red wavelength. If I go ahead and enable the Y option, you can see that we now have a second wave that is propagating just offset from this first one. It's a little bit tricky to see that sometimes, but the peak here is offset from the peak there. If I enable the EM shift, then that matches the peaks exactly, dead on, as you would see with electromagnetic radiation. So that is an option that I want to be available to people. And if we shut that off, we also have a polarized circular option. And so this is a kind of intriguing way that you can kind of see these represented sometimes. If we look at this from different orthographic views from the side or down the barrel, you can see it just looks like a circle, but this is actually propagating the wavelength along these peaks and moving in that direction, if you want to call it that. There's also a circular offset, and this is just to change the amplitude ever so slightly of the circular adjustment, so you can make it bigger or smaller. And that is mostly just so that you don't get intersection of the tops of the peaks with the circular wave when you're mapping that. That is, of course, radius dependent, so if you make this bigger, you might have to make the circular offset bigger as well. And all of this will adjust and work pretty much perfectly for any of these controls. So if I want to change the amplitudes will adjust accordingly. If I want to change the wavelength, let's go back to 580 for instance, then all of that will adjust accordingly. One of the things I've touched on is that the color will update based on the wavelength. However, there are options where you can customize that if you want something else. So for instance, we have a wavelength down here, and now we can actually set the different axes controls. So I've got one X, Y, and circular, and you can see I can make these whatever color I want. And this is just convenient depending on the data that you are trying to visualize. You can, of course, revert back to using the laser wavelength color or the specific wavelength color at any given point in time. And an interesting little fact about that is if we go further out, let's say to 750, where you can no longer actually see that wavelength of light, it becomes dark. And that's based on how the shader is set up. So as soon as you cross into the visible region, you'll be able to see that it starts to glow. And then as you move through the visible region, it will glow with all the colors that the human eye can perceive until you exit on the UV side, and again, you can no longer see that. So that's just an interesting little feature. Of course, if you want to be able to see a wavelength out here, then you can just enable the custom colors, and then it will be very clear what it is at any given point in time. Back with our 532 nanometer wavelength, you can see we can control the intensity. So the human eye actually also perceives color differently, sort of as brightness in an interesting way. Not fully versed in that area of work. But if you want to, say, have a red wavelength, let's go ahead and enable that, and we'll make this one red. If you want your red wavelength to appear as intense as the green one, then there is an option to change the intensity right down here. Say we make that 50, and now they sort of glow with a similar intensity, even though the green is actually only at a setting of 5. That's just a thing that you have to be aware of, and that has more to do with the human eye, less to do with Blender than anything else. Finally, there is a setting for controlling the material entirely. So the wavelength or custom material is one option, but there's also a rainbow spectrum material, which can be interesting. I am working on a version of this that actually maps this to a gradient wavelength across the length of the object, but that is coming in a future release. The asset also comes with some simple controls for modifying the signal amplitude within a defined range, and those can be accessed through the geonodes tab. When you go ahead and with your wavelength object selected, come to geometry nodes, you'll notice there's this little area over here for modify signal. The first thing that you want to do, other than come to rendered view, is enable the switch here. And you can see right away, we have a change in the amplitude that is confined to a certain region. And that is being handled by this signal multiplier node. It follows a factor from 0 to 1. So 0 is the start position and 1 is the end position. It works over a range, which you can define right here. So you can see that that is going to taper off towards the end of that range. And there is control for the signal multiplier. So you can make this bigger or smaller. You can also make this negative to bring values down to essentially 0. And because these are additive, if I go ahead and duplicate this node and add it to the path, connecting the modified amplitude in here, and then the modified amplitude out into the true socket there, then I can move this amplitude. And so when they overlap, they will constructively interfere, if you will. And that's not really what's happening because it's always additive. But if you move this along, you can see that you have the ability to control aspects of this in very tight ranges if you want, and to add in different signal changes. I tend to find that a range of a certain value is pretty necessary to get it to look good, if you will. And so, especially as you go to higher signal multipliers, you're going to want that range to usually be at least 0.2. This is a very convenient tool because you can animate this. So in addition to being able to animate the curve being drawn, you can now also animate whether or not there is anything present. And so typically the way that I like to do this is to start with a range of say 0, or to go from a signal multiplier of 0. Do that for both. You can see this is our generic curve. And now as we go up, our signal grows in. And so if we were to pause this briefly, and we'll come to a specific window I have for working with assets. And I just want this because it has a timeline. So we'll go back to the first frame right there. Come to the geonodes right over here. And I'm going to simply animate a signal multiplier of 0 beginning. I'll hit I to add a keyframe. Do that for this one as well. So in this case, we'll right click and insert keyframe. Then we can move ahead, let's say to frame 24. And I'll grow that signal strength in to just about there. We'll also add a keyframe for where it is along the curve at this point. And we'll change the strength here as well. We'll add that in. From there, I'm going to move another couple keyframes, and then I'll move this factor so that the wave moves that way, or the change in amplitude moves that way. And now if I were to reset everything, hit play, you can see our wavelength is going to grow up, and then that amplitude is going to move to the side. So that's a very quick and easy way of doing this, but it's something fun that I wanted to add to this. This also works on all the other components, so this will simultaneously update the circular and the polarized components if you're working with those. So you can see here, there we go, there's the circular and the polarized, and if we reset our animation, you can see all of those are going to change at once. And so that is just a fun feature that I wanted to build in. And that just about wraps it up. In a future version of this asset, I will likely try to make it possible to have different wavelength objects interact with each other to show interference. And I also have a prototype version of modifying the wavelength along the curve. I just have a few things that I need to iron out with that first. As mentioned at the beginning, there will be a breakdown in the future that actually runs through all of the node network in a little bit more detail to discuss how some of this is being set up, because it's a fun example of working with curves. So with that, thanks for coming out. If you enjoyed this video or found it useful, consider subscribing and sharing it with your friends and colleagues. A big thank you as always to my supporters on Patreon who help support the creation of these free assets and tutorials, and who make it possible for CGFigures to be a gold level supporter of the Blender Development Fund. Until next time, you have yourselves a great old day.